Well, good afternoon, everybody. This is going to be our first video over Lesson 1. It says Lesson 2 up here at the top, but that actually is a Lesson 1. Parent functions, we're going to introduce domain and range as well. This one probably will not be as long because you've already looked at the videos from Friday and you took notes over it. So what we're going to do is we're probably going to use our calculator, except a lot of the math right now is kind of easy, so I don't think you're going to need your calculator for this. And we're going to actually graph the parent function. We're going to talk about what we call the vertex, and we're going to also talk about the domain and range. So what we're talking about today then is the parent graphs. I'm also going to do, the next lesson is going to be starting about transformations, hence the whole unit is called transformations. A translation is when I move a figure, a parent function, left, right, up, or down. A reflection is when it, instead of opening up, it will open down. It flips over the x-axis. Dilation, kind of like your eyes, we're going to shrink or enlarge, and it's going to be called a stretch or a compression. Okay? Okay, so a stretch means like if I take the parabola or the absolute value graph or any of them and I grab it from end to end and I stretch it, it becomes thinner and steeper. A compression is if I take it from the top and I push it down and I just keep hitting it down and flatten it out, it becomes fatter. That would be a compression. So let me introduce domain and range. Domain is the set of all x values. X goes from, if you look at the coordinate plane, from left to right. That would be our x. Our range is our y values, which go from low to high, and each of our answers would be the lowest answer to the highest answer. Okay, and we'll talk about that. Okay, so let's go ahead and begin. So move this up, and we're going to look at absolute value. I'll kind of zoom in on it. And quadratics, okay? So, absolute value function, if you remember, if we were in class, I would say, what does this graph look like? Well, if you notice, there's two bars, so the graph is actually going to be our V, okay? So what we're going to do is we're going to figure out all of our vertices, or our starting point. Well, if you notice, there is nothing inside with the x, so our vertex is going to be 0. And there's nothing outside, nothing outside here, and that's going to be our y-coordinate, so it's also 0. So we are going to, let me change the color here so you can see a little bit better. We are going to graph the vertex 0, 0, okay, and that would be our starting point. So we know that the vertex is 0, 0. So what you're going to do now is you're going to pick 2 points on the right of the vertex. So if I look at that, that would be x would be 1 and 2. And then we're going to put 2 numbers, or the x's, that are to the left of the vertex. And that would be -1, and then -2. Okay, well the function, we're going to plug it in. The function is absolute value of x. Well, the absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of -1 is +1, and the absolute value of -2 is +2. So what this means in movements, okay, so if we go over to 1, and then we go 1, 1, that would be this point right here. And if we go over 2 and up 2, that would be that point right there. And that makes a straight line going to the right. Well, if I go to -1 and I go up 1, that's that point, and go -2 and up 2, that's that point, and I'm going to draw the same thing going the other way. So this is your absolute value graph. 2 bars, I get 2 pieces of the graph. Absolute value means only positive answers. That's why it doesn't go down into the negative. Okay? So now what we need to do is we need to talk about domain and range. So I want to shrink this a little bit and move it up. Okay, I want to get out a different marker. Let's see what we got. We're going to have to use yellow. Okay, so domain and range. So if I go from left all the way to the right, now listen, The point that's furthest to the left on my graph is an arrow. An arrow indicates as it's still going up to the left, it's still going left and left and left. So we go from -10 to -100 to -1,000,000. So it's coming from the negative direction from infinity. It never stops. It keeps going. Okay? Then as I go right, so I keep going right on the x-axis, so I go to 0, 0, then I go over to 10, 0, 100, 0. I also see an arrow. The furthest to the right is the arrow, but it's going in a positive direction, so my domain is -infinity to +infinity. Okay. Let's talk range. Well, range goes from low to high. So when we go low to high, we start down here, and we're going to go all the way up. Okay, so the lowest point on the graph is the vertex. Okay, whenever you have a V absolute value or a quadratic, you're going to start at either a vertex and go up, or you're going to start low and go high, and the highest point will be the vertex. Well, at the vertex, what is the y coordinate? Well, if you notice, the y coordinate 0. So our range is going to start at 0, and as we go up, 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 the arrows are the highest points on the graph, which indicate they keep going up and up and up. So that would be infinity. Infinities have parentheses on them, which means I never can touch them. It's kind of like flashlight tag. You try to hit the flashlight, and the light coming from the flashlight, and the people move it. They keep moving it. So since we cannot touch it, it means it goes on and it never stops, so you're going to put a parenthesis. However, the 0 is the vertex, and we can actually touch that point. So we're going to use a bracket, which is for the closed circle. That means 0 is actually included. I can touch it. It's part of the range. Okay? And that's your absolute value. Okay, so let's go ahead and go on to the next one. It'll go a little bit quicker. Okay, so we got quadratic. So if you remember, the quadratic is the U, and the U is called a parabola. So that would be like this. So if you notice, inside, there's nothing inside in parentheses with the x, and there's nothing outside. So actually the vertex is 0, 0 again. So we're going to put the vertex right there. Okay? This time we're going to pick, again, 2 points to the right of the vertex. So we're going to go 1 and 2, which would be our x's. And then we're going to go 2 points to the left of our vertex, which is -1 I don't know why that does that. -1 and -2. Might be because I was leaning on it. Okay, so 1 squared is 1, 2 squared is 4. -1 squared, if you put in your calculator, you've got to put parentheses around the -1 and square it, it'd be +1. And -2 squared is +4. Okay, so if we go through and we graph our parabola, we're going to go over 1 and up 1. We're going to go over 2 and up 4. So this is that part of the parabola. We're going to go back 1 and up 1. Back 2 and up 4. So the other part of our parabola is over here. Okay? So we have a U. That's our parabola. So let's talk domain again. So if we go, we'll use the red this time for, well, I'll use yellow again. We'll go domain. So we want to go left to right. Well, if you look at the furthest point on the left, again, it's the arrow. And since the arrow's coming from the left side and it continues on, that means our -infinity is our first x. It is our lowest x. And as we keep going to the right, the arrow is the furthest point to the right. So going from left to right, we go from -infinity to infinity. Most of our functions, in fact 3 of them, are -infinity to infinity for the domain. The square root function actually has a starting point, and that will change your domain and range. Okay, what about the range? Let's use red. Well, the range, then we want to go from low to high. So if I go low to high, the lowest point would be my vertex again. And the y at that point would be 0. So the y coordinate, and remember when we have a number, we're going to put a bracket around it. And as I go up and up and up, the arrows are the highest points that they go, so that would be infinity. So my range is 0 with a bracket up to positive infinity. Okay. Okay, so I want to continue to push this up. Let's look at the cubic function, and the cubic function is going to actually be very similar to the last two we've done. A little bit different. If you remember what the cubic function looks like it starts low and kind of goes up high. Okay, well, if we look at that, our starting point, there's nothing inside with the x or outside, so that means our vertex is going to be 0, 0 again. It's actually not called a vertex. This is called our starting point. So our starting